Hello, we're going to talk about period for pendulum. Okay, so let's draw a pendulum. So this is the bob, it's called the bob, which is the mass. And this is my theta. And the length is going to be called L. So then there's an arc right there. Okay, so then this arc is going to call S. So S is the arc. In Chinese is Hu, right? Right. So we're going to look at the free body diagram. So for this M, the free body diagram is going to look like this, FBD. So this M, it's going to have, so we're going to call this one FT for now. So that's force, but this is a tension, right? Instead of calling T, because we're already using T for period. So we're not going to call T, we're going to call that tension. And then we're going to have this one here as the mg. So we're going to break this. This is also theta. So this is the mg cosine theta, which will be canceled when we are at that position when velocity is equal to 0, right? If that's equal to 0, mg cosine theta. So you start from the rest right here, okay? So start from rest. So anyway, this is the mg sine theta. Mg sine theta. Okay? So mg sine theta is the force that's driving your motion right here. Okay? So this is going to be calling F. So this F is responsible for the tangential, right? This is the tangential acceleration. Tangential, right? So responsible, right? Responsible for tangential acceleration of this ball. This ball is going to accelerate and come to the maximum velocity right here. Okay, so this F, we're going to call that mg sine theta. Okay? And if the theta is small enough, let's say less than 5 degrees, okay? Then in from mass, sine theta, it's pretty much equal to the theta, and this theta would be in radian, right? Okay? So if you put the 5 degree in there, you can actually make sine theta to become theta and in radian. So then this one here, we can then almost approximately equal to mg theta. Okay? And now from here, we can have this relationship, S is equal to L theta. So theta is equal to S divided by L. So we're going to put this one here into this formula. And that's equal to mg S divided by L. Okay? All right. So then this is the force. And we're going to rewrite it as mg L times S. Right? So S is kind of like the displacement, right? So we're going to record this here in the SHM. Remember in SHM? In SHM, so we're going to recall SHM, right? Recall SHM. SHM says the force, the restoring. Restoring means you try to bring it back to the equilibrium, right? Bring back. 就是恢复的 okay? 恢复的 in Chinese. Right? Restoring force. It's equal to minus K times X. Okay? And this X is your displacement. So the S here is considered the displacement too. So you can see this K in the pendulum, this K becomes the mg divided by L. Forget about the negative sign for now, okay? So K is similar to mg divided by L. So that's what we want. So K is kind of similar to the mg divided by L, right? So now let's go and look at our relationship. I'm going to change in color again. Remember the T for the SHM is equal to m divided by K, right? So we're going to put this K as mg divided by L in there, 2 pi. Then we have m, and then we have mg divided by L. So L is going to go on top, right? So M cancel out. So then this period for the pendulum become 2 pi L divided by G. All right? So this is the formula for the period of pendulum. Right there. Okay? That's what you are looking for. So this is the period for SHN. But this one here is for pendulum right there. Okay, that's all we have. And thanks for watching. Until next time, bye-bye.